So this is really a continuation of work we did earlier on we used our TVM solver, or one of the applications on our GDC, in order to solve a number of problems involving compound interest. And here we're looking at building on that by looking at when we have payments, either where we're trying to pay off a loan or where we have an investment that's paying us back until it runs out. And so if I look at this first example here, say you want to have a mortgage, and the mortgage rate will be $475,000. And we're planning on an interest rate of 3.75% per annum per year, but we're going to be making monthly payments. And so if we want to pay this off over 25 years, what must those monthly payments be? A pretty standard sort of thing to think about when the time comes to pay for overly priced real estate. And so for something like this, the mortgage amount, that will be our present value. And so I'll call that $475,000. If we want to pay it off, though, the key is our future value will be zero. So any questions where we want to pay off a loan, we want to think about our future value being zero, our present value being whatever the loan is. And there's many types of loans. The interest rate, as we can see, is 3.7%. So I just write 3.7. N being the number of compounding periods, or in this case, it's 25 years. But we're making monthly installments, so it's 25 years times 12, which is 300 installments in total. The PMT, this part here, this was unused in earlier lessons. That stands for the payment. In this case, the payment we will have to make each month. Well, that's what we're trying to figure out. So this is what we will solve for. And so remember, again, we leave that as just any number, as zero. And then in a moment, when we have everything else filled out, we use our GDC to solve for that value. The PY, the CY, the payments per year, and the compounding periods per year, again, always the same in general, and so 12 because we're making monthly installments. So we're compounding this interest monthly. So with that set up, we solve for the payment, and we should get, as usual, a fairly messy decimal. That's approximately 2,429.2154, and the decimals go on. That's our payment. Now, I believe it'll actually show up as a negative on your screen, and that's because that's how much we're removing from our debt each time, but our payment is a positive. I'll just say our payment is a positive number, but quite often you'll see that's a negative, which makes sense because we're removing our debt. That's it. I want to have this, it doesn't say how I should round this, and so the default is always 3 significant figures. And so to 3 significant figures, this is $2,430 per month. And so going forwards, unless it's otherwise stated, I will always round my answers to 3 significant figures. Well, if you paid $2,430 roughly dollars a month for 25 years, by the end of the time it's paid off, you've paid a bunch of interest because the bank wasn't being just nice. The bank was making money off you by charging interest. So how much interest did I pay over these 25 years? Well, the key first is to figure out how much did we pay in total over 25 years, which I don't want to take my rounded amount. I want to take my decimalized amount. And I want to realize I paid that 300 times. 25 years times 12 times a year. So I want to take that value there, 2,429 plus change, and I want to multiply that by 300. And that will give me roughly 728,764 and change. And I'll just write down a couple decimal places. So that there represents how much money in total after 25 years I've given to the bank. Keep in mind, the actual house cost or apartment, whatever it was, cost $475,000. So the interest is the difference between that. So I want to subtract from that the $475,000. And when you do that, you get a considerable amount. You get around $253,764 and change to 3 significant figures. It's $254,000. So keep in mind that is how much interest the bank has made off us, should I have paid this off over 25 years. It's a lot of money, but that's how banks make money. And keep in mind, there's a lot of risk in many ways, but there's also how a small change in interest rates over a long period of time can make a big difference, because that's nearly half the price of the purchase price is just, we're paying extra in interest. So another common type of loan is a car loan, and where I have a bit more here, we're looking at the purchase of a car with a sale price of $52,000. The dealership is offering financing for 4.2%, annual interest rate, but on monthly payments, and a 7-year term. Buyers must pay a 10% deposit. So if you want to use this financing offer, you need to put down 10% on your own, and then the financing on the rest. It then says by the time you actually decide to purchase this car, the interest rate has gone up to 5.2%, so you will clearly have to pay more interest overall. The question is how much more interest? Well, let's first ignore the change in interest rate and think about just the original 4.2%. And so keep in mind, either way I want to look at this, the $52,000, which is the sale price, is not what we'll be using in our solver, because I need to subtract 10% from that, which is the same as $50,000 times 0.9, keeping 90%. And so the actual financing amount will be 90% of 52,000, or 10% less than 52,000, which is 46,800. So that is going to be the number we use for our solver. That's how much money the bank is basically paying, and we are then paying them back. The other 10% is what is our deposit, and that's not going to change depending on which interest rate we have. So that's the more important number for this question, 46,800. So now let's look at the interest rates. When we have 4.2%, the lower interest rate. Well, thinking about my solver, the number of compounding periods will be 7 years, because it's a 7-year loan, times 12. So 7 times 12 is 84 compounding periods. The interest rate is 4.2. The present value of the car is not the $52,000, it's what we're actually getting financing on, because we have to put down a deposit. So that's the $46,800. The deposit we're just paying for, there's no financing on that. The payment we're trying to figure out. So the payment is what we will solve. And I'll get to that in a bit. The future value will be when the car is paid off. And so that is going to be, again, 0. Payments per year is 12. Compounding periods per year is 12. So this is what we want to solve. And so when I do that, I quickly get a number with more decimals than I need, but I get approximately $644 and change. That said, that's what my payments will be each month if it was 4.2%. So I'm going to leave that there for now, and then do the same thing if it was 5.2%, which is all going to be exactly the same, except the interest rate will change. So I can use the exact same values, but this time instead of 4.2, my interest rate will be 5.2. Everything else is the same. So when I go to the payment, it should be nice and quick. I go to solve, and I get a slightly higher amount per month, which makes sense. I get $661 and change. All right, so now the question is, what's not the difference between these payments? What's the difference by the time the car is paid off? And so keep in mind, this is each month, but there's each of these I want to multiply by 84. Because 7 times 12 is 84. This is over 7 years. And so over 7 years, if I locked into the 4.2%, I would pay a total of $54,097. And I'll round to the nearest dollar. That was at 4.2%. If I didn't finance it till it was 5.2%, it would be a bit higher. It would be $55,563, round to the nearest dollar. And so what's the difference? Well, I want to subtract these. And so the difference to 3 significant figures is approximately $1,500. Right, last question. Looking at me. I'd like to retire when I'm 60. Why not? It's a nice number. And I hope to have $800,000 in an annuity plan. Now, an annuity plan is essentially an investment in which percentage is paid back to you. It's kind of the reverse of a mortgage, you could think of it. And we're saying I have a plan in which I will be receiving 4.7% interest annually. But will be getting monthly payments back. So it's the reverse. I'm having money coming into me based on this investment I have or money I've given to the bank. For the first part of the question, I plan to withdraw $4,500 per month until I run out. So how old will I be when I run out? Well, similar setup. Use my solver here. So N is going to be what we're trying to figure out. How many periods will there be in the end? So I'll get to that in a bit. I don't know, but the rest, the interest rate is 4.7, or you could say the rate of return. The present value is the $800,000 when I'm 60. That'd be nice. The payment is going to be the $4,500, but I'm withdrawing. It's being taken out from my amount, so I have a negative $4,500. The future value is when I run out of money, and again, these are monthly installments, so these are both 12. So when I solve for this, that will tell me how many compounding periods, and I get roughly 304.9. So now that is in months because these are monthly installments of 4,500. So I now want to convert this into years. So this is approximately 25.4 years from when I'm 60. And so how old will I be if this ran out? Well, 60 plus 25-ish. And so I'll be in my, I will be 85 years old when this happened. So when whoever's writing this is 85 years old, I'll run out of money. Right? Almost halfway through when I'm 85 years old. All right, that's pretty nice, but I'd like to live longer than 85, and I'd like to not be broke. And so another option is, okay, what if I want to make it last till I'm 100 years old? So how much money will I be able to take out each month? So it's a very similar setup. This time, the N, I'm going to know what N is. N is the number of years from 60 to 100, but times 12. So it's 40 years times 12. Is 480. So to make it to 100, that's 480 installments. Interest rate's the same as before. The present value is the same as before. The payment is what I'm trying to figure out this time. Future value, everything else same as before. All right, so this time I solve for this. And I get approximately to three significant figures. Or actually, here I'm asking for the nearest dollar. So I get to the nearest dollar, I get approximately $3,700 per month. And so that little bit of difference from $4,500 a month will last an extra 15 years.